The engines, equipment, ploughs and the other implements for cable cultivation, together with the methods of operating with them, were largely developed in the 1850s and 60s and operated for about 100 years, but had pretty well ceased to be used by the early 1950s. Fortunately, enthusiasts ensured that some of the engines and equipment were not scrapped and have therefore been saved and preserved and are regularly demonstrated today. In days gone by, those operating ploughing engines and tackle would have done so on most working days, and so preparation of the engines and equipment will be second nature to them and an almost automatic activity. But for those about to operate ploughing engines, equipment and implements today, there is a need to ensure that they observe and follow the correct procedures to be able to do so safely and effectively. To better understand what needs to be attended to before each working session, here's a look at the parts of a cable cultivation engine that are not to be found on a standard traction engine. For this, we hear from someone who has worked with cable ploughing engines for many decades, Michael Davies.
Well, the important thing I think to remember is that a ploughing engine is made with a slightly longer crank, which has 3 bearings instead of 2, and between the 2 extra bearings there's a bevel gear, which drives directly onto a vertical shaft, and at the bottom of the vertical shaft there's a dog clutch which you can drop in, but it's a one-way clutch, so that if you turn the engine the opposite direction it drops out of gear.
This then provides the power train from the crank down to the cable drum pinion to drive it when winding in. Although the lubrication reservoirs and locations for oiling may vary from engine to engine, Michael takes us through what is needed on this BB1.
All the lubricating points on the crankshaft, as are most of the others on the engine, are wick-fed oil pots, which includes the extra one on the end, so that they're normally filled with an oil can until they're full, making sure that the wick is working every time you re-lubricate. Make sure it's used some of the oil. But as far as the rope, particularly the rope drum points, these are mostly fed from this reservoir, which, as you see, opens up, and it's got 3 wick points inside it, and you just fill it up with a jug like that. And sometimes a good idea to let some actually go down the middle pipe. And when it's more or less full up to the level of the baffles, shut it up to keep the dirt out, and that's that. And then we have to have a look at the other end to see where it feeds from there.
The main oil reservoir Michael was filling has 3 pipes down from it, so that by gravity oil travels down to the main areas on the drum drivetrain and the drum itself. But the implement or implements to be used will also need preparation prior to the start of work. All types of implements used in cable cultivation are by their very nature robust, but as well as needing to be set up correctly, which is covered in the next section, the moving parts also need checking and lubricating. Some are obvious, others not so. In this case, it's a plough.
So I'll put a few pumps in here. Oil for the threads where we alter the height of the plough. Lubricating the steering mechanism here. A little bit of oil on the worm. Grease nipples are here and it's under there. At each end on the knuckle joints. Oil on the threads.
Joe has given us a good guide to what needs attention. Greasing where required, oiling the threads of adjusters and topping up oil reservoirs, particularly for wheels. But each implement, even of the same type, could be different, so get to know the ones you are using. They will all have similar lubrication points. Here, the rope from one engine has been pulled out to the desired distance, so having ensured that both engines are correctly aligned and square onto each other, the next task is to connect the rope to the implement. Once at the implement, the two cables are separated again, and utilising shackles, the ropes from opposite ends are secured to the two connecting points on the implement. The shackle pin should be screwed in from the top to lessen the possibility of it coming out during operation. As this is where the pulling power of the rope is applied, it's important that after screwing the shackle pin in, it is then tightened to secure it. Once the ropes from both engines are connected, the next stage of setting up the implement can take place. If, as here, it is a plough, the height of the plough shears in relation to the ground needs to be set. To do this, the main frame of the plough is adjusted so that it is parallel with the ground. The plough frame must be level in all directions and set to plough at the correct depth. One wheel of an implement, like a plough, is larger and narrower than the other. When working, this is the wheel that runs in the furrow, whilst the smaller but wider wheel runs on top of the uncultivated surface. This is ideal for working, but to make for easy movement when travelling, the frame is adjusted accordingly, and this makes the bed of the frame somewhat canted and therefore not level. So to work effectively, the height of the frame has to be adjusted so that it becomes parallel with the ground. This is achieved by turning the screw thread adjusters, thereby raising or lowering each side of the plough frame. For this particular plough, the adjusters are locked into position by this restraining chain. This is removed and a ratcheted wrench is fitted onto the top of the adjuster. It is then rotated to change the level of the frame in relation to the ground. Each side is adjusted in turn until the frame is level. Once done, the adjusters are secured to ensure they cannot move. In essence, working is the pulling of the implement back and forth across the field to plough or cultivate it. Mechanically, that is achieved by each engine in turn providing the pulling power, whilst the other with its drum mechanism out of gear allows its rope to be fed out from the winch drum. The implement being pulled by the rope is steered by the ploughman or steersman to keep the work straight and to ensure a clean end to each pull. This really is a team activity and will not be efficient, effective and remain safe unless everyone involved works together and anticipates and readies themselves for the next part of the operation. So once given the signal to start, the operator of the engine winding in engages the drum drive gearing and then starting very slowly accelerates. The very slow starting speed is vital to allow for a gentle increasing tension on the rope to safely move the implement into position for the run, slowly swinging a cultivator or harrow around or assisting the plough team to tip it into position and to get back onto the implement. Once a cultivator or harrow has been turned, or the plough is into the furrow with the crew on board, the engine can be steadily accelerated up to the best operating speed. Throughout the pull, the engineman must concentrate on the progress of the implement, particularly watching for any signals which might indicate that action is required to stop the pull, speed up or slow down, and in particular, adding additional coal to the fire or working the injector should not happen, as the driver must keep an eye on the moving implement at all times. In the last part of the pull, de-accelerate down to slow speed to allow the steersman to move out of the furrow and into alignment for the next run. Disengage the ploughing clutch as soon as the implement comes to a halt. Once the implement has stopped, remove the blocks and move the engine along the width of the work, ready for the next pull, having the blocks replaced after the move. always, putting wheel blocks in place is clearly a must-do. But, particularly when working on any degree of slope, the positioning and shape of the block should be considered. Remember that when working, the engine does in effect have no brakes, and it is only the wheel blocks that stop the engine moving and possibly running away. Michael explains about the considerations required. So, having seen the actions required of the operators of the two engines, what is required from the steersman at the commencement of, during the run, at the end of the pull? The tasks do differ a little depending on whether the implement is a plough or something different, such as a harrow. For a plough, the steersman and others with it need to be ready to assist with getting the plough frame down as the rope comes under tension and begins to be wound in. Everyone involved needs to be in the right position as the initial momentum takes the plough forward at the same time as the rear of the frame comes down. Therefore, the signal to commence the pull isn't given until everyone is ready to start. With the rear of the frame down, the steersman needs to be quickly onto the seat and taking control of the steering so that the plough is straightened and the narrow furrow wheel is directed into the open furrow. As the plough approaches the pulling engine, the engineman will slow the progress of the pull so that the speed of the implement decreases. As it slows, the steersman turns the plough out of the furrow, turning the front of it away to the side for the last few feet, but then straightening up in readiness for the start of the pull back across the field. As the plough comes to a halt, close to the engine, the crew dismount and take up position at what is now the rear of the plough, ready for the next pull. For a cultivator, or as here a heavy harrow, the process is similar but with some differences. First, other than for the very first pull, the implement and therefore the steersman is still facing towards the engine that was just winding in, and therefore away from the pulling engine. As the pull commences, the rotating arm mechanism is swung around by the tension on the rope, which then turns the whole of the implement until it is facing in the correct direction. And at the same time, it's lifting the implement out of the ground. It is during this movement that it is possible for the rope to become tangled in the swinging arm mechanism or on the implement, requiring the pull to be stopped. Once fully round and beginning to move forward, depending on the particular implement, it will be necessary to drop the harrow tines or cultivators down into the ground so that they can do their job. As the pull progresses, steering and controlling the implement is a straightforward process.